Here we are at section B. Hopefully you've got a good understanding of how section B is set up. There are 15 questions, each worth 2 marks, so 30 in total, which means we have 54 minutes per question. However, it's based on 3 cases, so each of those cases is 5 questions. Probably a better way to look at it is we've got 18 minutes for each case, and each case will have 5 questions. Some of those will be relatively quick, some will be requiring a lot more of our time, and what we should aim to do is use 18 minutes to answer those questions. And I will show you my method where I try and identify the easier ones, the quicker ones, get those answered first, and then I've got more time that I can allocate to the slightly longer ones. But what's very important is when we get to the 18 minutes, we should stop that question and move on, because there's some low-hanging fruit in the other section B questions that we should be trying to get first. So 18 minutes for each case. We will identify, normally it's 1 or 2, which I call an outlier. We'll answer those, bank those questions, bank some time, and then the residual time we've got left, maybe it's 16 or 15 minutes, we can spread over the remaining questions. If there are 3 left, then we've now got 5 minutes for each of those 3 questions that are left. Section B will have narrative like this, which applies to all of the questions, and then each question will be set up on the right hand side, sometimes with some additional information which is specific for that question. And what I do is I go hunting for the outlier, so I actually click through these and see if I can find the outlier. An outlier to me is a question or questions that do not really need this information. And as I just said, one of the reasons to do this is they're often easier and faster, so I get the easy marks, I save some time or bank some time, but also because I'm going to quickly look and see what each question is asking. When I then come back and read through this, I've primed my brain to know what it's looking for. So it gives me context so that when I read through this, it's then going to link back to questions which I know are coming. I can see this as a calculation where we need to calculate the expected value. I can see it's a decision tree, so that's not an outlier because I definitely will need the information here. We've got to choose the optimum course, and I can see again there's a calculation involved there. This is a maximum price for market research, and I have to do a calculation, so that's not an outlier. Which of the following best describes the value of imperfect information? This is an outlier. Imperfect information doesn't come up very often. Perfect information, it relates to risk when we can use probability to determine how likely something is to happen and how much would we be willing to pay in order to eradicate that probability and know for certain what's going to happen. Imperfect information is not as good as perfect information, but it's better than no information. A good example might be if we were selling ice creams and we know if it's sunny, we'll sell a certain amount, but if it's rainy, we know it'll be lower. If it's overcast but cold, then we know it's a different number. We can't know definitely what the weather's going to be, so we can't get perfect information, but we could look at a weather forecast. That would be imperfect information because they're not always correct, but that could help us decide how many ice creams we stock on that day based on the weather forecast. So with that in mind, which of the following best describes the value of imperfect information? Option 1, the value of imperfect information is always lower than the value of perfect information due to the uncertainty of such information. Now, although my default is when I'm given an absolute in a multiple choice, assume it's incorrect until proven otherwise, this is actually the correct answer. It is true that the value of imperfect information is always lower than perfect information, and it is because of the uncertainty. So that's correct. Using the scenario I just mentioned, a weather forecast is imperfect information. If I invented some system that gave you an absolute definite prediction of what the weather will be, that's going to be more valuable than the weather forecast, which can be wrong. Let's look at the others. The value of imperfect information may or may not be lower than that of the value of perfect information, as it depends on the extent of uncertainty. That's not true. That's in conflict with the correct one above. The value of imperfect information can be derived without considering the probabilities of the uncertain information. No, it's all based on probabilities. That's how we can calculate the value of perfect and imperfect information. The value of imperfect information is the minimum cost to be paid for obtaining such information. No, it's the maximum cost. So that's an outlier. Question 20. Which of the following is not a characteristic of an outcome point in the decision tree? So once again, this is an outlier. A decision tree, or the design, if you like, of a decision tree is it has outcome points and decision points. A decision point is where we make a decision and is normally a square or a box. And an outcome point is a point at which we calculate an expected value and is normally denoted by a circle. So which of the following is not a characteristic of an outcome point? So we're talking about the circles in a decision tree. The occurrence of outcomes at this point is beyond the control of the decision maker. That is true. So remember I said the decision is made here. The outcome is based on this unknown, and we use expected values and probabilities to find out the value at that point, but we cannot control it. So that is a characteristic, so it's not correct. The sum of the probabilities of all outcomes at each chance fork may not necessarily equal to 1 or 100%. That is false, that's incorrect, so that's the answer. Everything that feeds into a decision point, i.e. the fork, has to total 1 in terms of its probability, or 100%. A decision will not be made at an outcome point. That's true. Decisions made at a decision point. There could be one or more outcomes at an outcome point. No. Each outcome is as a result of a decision, and we cannot have a second outcome at the same point. So the correct answer is just that one. We found 2 outliers in this question. So 2 of the 5, i.e. 4 marks, were based on outliers. That would normally take 7.2 minutes, but we have probably done those, even with me talking around the point, in 2.5 minutes. Let's assume it was 2. That means we've now got 16 minutes for the other 3 questions. We've also had a look at what's coming up, so that will help us when we read through this. You may still want to be strategic in your approach. You may think that some of these calculations are going to be easier than others, and you might want to choose to do those first. I'll do them in order, but let's look at what we're told. So here's the scenario. Alco is one of the leading graphics processing unit manufacturers in Yeeland. Given the geopolitical unrest in the region, the board of directors is currently exploring alternatives pertaining to one of its factories, located in one of the countries that's been severely affected by the regional uncertainties. Currently, there are 3 alternatives under consideration. Alternative 1 is full expansion. Alternative 2 is partial expansion. Alternative 3 is closure. Should alternative 3 be selected, there'll be guaranteed proceeds from the disposal of all existing assets. Based on Alco's management team, it's expected the total estimated net cash flow, ignoring a time value of money, of alternative 1 and 2 will be subject to different states of demand, which is currently uncertain. And there's a 70% chance of high and a 30% chance of low demand. This is summarized in the decision tree below. So you see at decision point, they can either choose to expand fully, expand partially, or close. If they close, they're guaranteed to get 5.5 million. If they partially expand and there's high demand, they'll get 6 million. If they partially expand and there's low demand, they'll get 2 million. And there's a 70% chance of high, 30% chance of low. If they do the full expansion, then if there's high demand, they'll get 9 million. But if there's low demand, they'll lose 3 million. So we need to work out which of the following options is the expected value. And it's asking us for point B and point C. I'd like to point something that jumps out to me here. Point C, option 1 and 2 and option 3 and 4 have the same. Whereas for point B, they're all different. So if I just do the calculation for point B, then I should be able to answer the question fully. If I do the calculation for part C, I'm only going to eliminate 2 of the options and still have to do the point B calculation. This is a time pressured exam, so I'm going to be really efficient. I'm only going to do a point B calculation. So at point B, if there's high demand, that means a 70% chance of getting 9 million and 30% chance of losing 3 million. So the calculation is 0.7 multiplied by the 9 plus 0.3 multiplied by the minus 3. Now it doesn't like that, and that's why it's good to practice on the exam platform. I haven't used this calculator before, so there's obviously a different way I need to be putting in that calculation. So I've reconfigured the calculation, moved the minus out here. So this gives me 5.4, so it has to be option 4 is 5.4. Just for the benefit of the video, I will do the point C calculation, but like I said, I wouldn't do so in the exam. So once again, it's 0.7 by 6 this time. Now we do a add on 0.3 by 2 is 4.8. So it agrees that it was either going to be option 3 or 4 based on the point C calculation. option 4 the correct answer. What is the optimum course of action and the resulting expected value? So it's basically asking what choice we would choose. Is it 1, 2, 3, full expansion, partial, closure? I'd be very surprised if you got this in the exam, because if we look at what it's got here, it's given us the two calculations that we worked out in the prior question. On occasion, you do get a bit of information in one part of the question that helps with the other, but not normally as blatant as this, that it gives us the two calculations. But as it has, we're reassured that the calculation that we did in question 16 is correct. Which would you choose? We would always choose the one with the highest expected value, and that's alternative 3 if we're just making a decision on financial reasons only. So that's closure is the one that gives us the 5.5 million. And then the market research company proposed to Alco that they can provide an exclusive version of a market research report with a guaranteed forecast on the state of demand at a premium price. What's the maximum amount they should be willing to pay for this exclusive version of the market research report to the nearest 2 decimal places? This is a what is the value of perfect information question, and we calculate the expected value without perfect information and the expected value with, and the difference is the maximum amount we'd be willing to pay for that information. So the expected value with is worked out by what we would do if we knew what was going to happen. So this research report will tell us whether demand is high or whether demand is going to be low. If it tells us that demand is high, which of these options would we go for? Well, we can eliminate the low demand ones. So our options are either to make 9 million, 6 million or 5.5. We would choose to make 9. So if it tells us demand is going to be high, we would choose full expansion and would make 9 million. And there's a 70% chance that the report will tell us that demand is high. So we do a 0.7 times 9. If demand is low, we get rid of this one, we get rid of this one. So we can either choose to lose 3 million or make 2 million or make 5.5 million. Well, we would choose the one with the highest. We would choose to close and make 5.5. And we know there's a 0.3 chance of there being low demand. So that's the calculation we need to do, 0.7 times 9 and 0.3 times 5.5. I suspect a lot of students did 0.3 times 2 if they got this wrong. But remember, we would always choose the one that gives us the highest outcome financially. So it's 0.7 times 9 multiplied by 0.3 times 5.5 is 7.95. With this report, we would have an expected value of 7.95. Without was what we chose in the previous question is 5.5. So the difference is 2.45 million. We want it to 2 decimal places, so 2.45. And that's the end of this question, Alco.